Hello everyone. So in the day 5 session, we are going to cover basically basic neural network architecture, or that is called perceptron also. We will understand what is the perceptron, how actually basic neural network is connected or how it is designed. We will take an example and we will understand how you can utilize this neural network concept in your daily life as well. So we will cover all those things one by one. First, let's start with a simple example. I'll take a real life example. Okay, tell me one simple thing, that have you ever taken any tough decisions in your life? Or I would say, let's take this thing that have you ever thought of leaving a job for a data scientist role, or maybe you want to take a decision that should you go for you. Let's take this example that you are getting a job as a data scientist to some company. Okay, for that you are not sure that you should take that offer in or not. Okay, you are just confused with so many things. And why you are confused? There are some evidences, or I would say there are some factors on which your decision is based, and you are not very sure that should I go ahead with this particular offer that company is offering, maybe with whatever package or whatever is the experience or role they are offering. So if you want to make a decision as a normal life, how you make that decision? You think about lots of things, you take advice from your friends. But if I ask you, or if I tell you basically that this problem you can solve logically as well. Logically means you can definitely solve this problem with the maths. The only thing that you have to do is you have to write down the factors which are affecting your decision. Okay, let me give you one more example here. Suppose I am getting this job as a data scientist to some XYZ company. Okay, and my why I'm thinking my decision is based on three factors right now. That it is basically providing me higher salary or not, or it is providing me equal salary. Okay, and maybe it is providing me work from home, or it is providing me work from office location. And maybe you are now more comfortable with work from home, you are staying with your parents, you are not interested in leaving this work from home thing, so that's the reason you are thinking about it. And third one is maybe the work or the role that they are giving you as a data scientist also, how it is, how the companies are they growing. Okay, or maybe the work, is it research kind of work, it is more or a deployment kind of work, or exactly whatever role they are assigning to you, it is good or bad. Okay, you are not sure about it. Okay, or maybe I would say, let's not say good or bad, maybe it's more relevant to you or not. Okay, these are the three factors on which it depends. Okay, suppose if your all three factors are positive, or I would say one, okay, then you can say, okay, I'll definitely take that job, no issues in that. But you are thinking, because might be one or two factors are not in the favor. Maybe that is, they are providing work from office, you want to do work from home. Now you don't know which one to choose, or I would say which one weights higher. Okay, then how will you solve it? Okay, I give you one more thing. Suppose these three factors that you have taken here, let's consider this is 1 x1, this is considered as x2, and this is x3. Okay, if I say x1 equals to 1, I'm just converting this normal problem to a mathematical one. Okay, so if I'm saying x1 equals to 1, it means the salary is higher than you are having right now. If I am saying x1 equals to 0, means either it's the same or maybe it's a low. Okay, similar thing, if I am saying x2 equals to 1, it means I am getting basically work from home. If x2 equals to 0, I can say I am getting work from office. Okay, and the third thing, x3, I am saying if it is 1, it means maybe the role is more relevant. Okay, and if I am saying x3 equals to 0, it means it's not relevant. Maybe even for a data scientist role, maybe they are giving you a data cleaning, or maybe just data collection, which you might not be interested. Okay, so you have to first ask, okay, what kind of projects I'm going to get. So many things are coming up. Now you have mathematically written that But it's not like that all the factors are equivalent. Okay, it's like, for you, suppose you are the person who wants to stay with family, that matters with you the most. Or maybe for you, you are the person for that job, how much job is relevant, that matters the most. Okay, so you might have a different choices, and in that case it will be very difficult for you. So let's do one thing, let's decide that what is more important for you. I am saying, okay, I am that kind of a person for whom this is more important, that work should be good. Otherwise, anyway, I am working on a job already, right? So if this is the case, I'll say this thing I'm giving more weightage. Okay, let's define that weightage. Okay, or I would say that is called w3, just term I'm giving the name. Let's define some number. That number I'm defining randomly, the only I have to show it here, that okay, this is the highest weight. Or let's not take 6, let's take 4. Okay, and here I'm defining this weight w2. Okay, it is as a 2. Or maybe this work from home and higher salary, two things matters the most. Okay, so let's give them this as a 2 number. Okay, so now you have given the weightage of this thing. So now when you have to make a decision, can I say that if your salary is high, okay, and also you are getting work from home, okay, then even if work is, or I would say the work is not relevant, then also you should get this role. Okay, you should accept the offer. I would say you should accept the offer. Or maybe I would say, even if your salary is not increased, or you are not getting work from home, but you are very happy with the relevant work. Okay, maybe you are happy with the relevant work, so you are saying, okay, let's accept this. Okay, accept the offer. Okay, or maybe you are getting work from home, all the three things you are getting together: high salary, high salary plus work from home plus relevant work. Okay, then I would say, then again you are accepting offer. So there are multiple conditions, but you are saying that when I'm saying this thing and this thing I'm getting, and weightage is not equal in this case, so I'll say, okay, let's keep some threshold. Okay, I can say, okay, I agree, but it's not like that salary should be increased too much. But even if suppose if I am getting a 5 lakhs package and I'm getting 6 lakhs after this, so I am comfortable with that. Okay, so for to understand that, or like how much I am willing to get this job, or how much I am interested, to showcase that I am keeping a threshold. And let's keep that threshold as let's keep that threshold as 4. Just random number again I am taking. Okay, let's keep that, sorry, this should be, let's keep that threshold as a 4. Okay, so now I have mathematically written them, I have kept the threshold 4. Can I write it like this: x1 w1 plus x2 w2 plus x3 w3? This complete equation should be greater than the threshold. If this is true, I can say, okay, I'll accept this offer, or I would say I should accept this offer. I'm not saying I'll accept this offer, but logically I should accept this offer, because it is actually completing all of my bare minimum requirements. Can I say this? Definitely. What is the problem here? Okay, so if I'm saying this, that okay, in that case, when x1 equals to 1, let's say if I'm saying x1 equals to 1, and what is the w1 here? W1 here is a 2. I am saying 2 plus 1 into 2. Then it does not matter what was the x1 here, it is the salary. Okay, x2, what was I have get, x2 is work from home, this is relevant work. Okay, so even if the work is not relevant, but it is crossing it, I can take the equality for now. Okay, so I would say 2 plus 2 equal greater than equals to 4. Then okay, it is on the verge, I would say. Okay, so I can say I'll accept this offer. Okay, or maybe I can say if salary is high and also I am getting work from home, which is generally 6, which is definitely greater than or equals to 4, then I can say again in this case also I'll accept this offer. Right. So are you getting this logic now, that how it is working? The similar thing that I have kept it here, no, I'm just keeping it or I'm writing it mathematically. Okay, let's do this. I'm using a summation sign. I'm keeping it xi wi, which I means it is iterating. Here I would have 1 1 2 2 3 3, and here because I have three factors on which my decision is depending, I am keeping I equals to 1 2 3, and it should be greater than threshold. This is how human decision work, not exactly I would say, because human brain is more complex, but at least the basic, very basic element or basic key is this is called a perceptron model, where you have nothing, you have just one element, I can say. Let me say it like that. Okay, this is x1, x2, x3, this is my input neuron. Okay, here you are feeding it to some equation. This is w1, w2, w3, and after that you are passing it through some threshold function. I would say here you are doing summation and you are passing it through some threshold function. Okay, and then you are getting the output. Okay, this is how your basic neural network architecture is designed. Now let's go a little complex, because as I said that human brain does not exactly work like. Why did I say this? Because human brain takes lots of more decisions into, or lots of more evidences take into account, and also there are different layers, certain decisions after that also they take decisions, their experiences, lots of things are there, right? So let's do one thing, let's make it little complex. As I said here, I can do one thing here. When I'm getting one output, okay, one submission, one way, okay, then here I'm getting just one output, correct? But when I checked here, there are multiple cases possible, right? There are multiple combinations can be possible. So if I take the multiple combinations into the picture, then I can say this is my input, okay, and this is my one output. I'm directly keeping it output here, okay. Just you can assume that here I'm applying the threshold. So now when I'm now suppose if the one output that I have taken, based on different condition, I am taking different other outputs, okay. So these are the different outputs that I have taken, and then based on that condition I am again sending it that output to some other layer, okay. This is what I am doing here. I'm sending all those output to some other layer, and now I am getting the final output based on that. Okay, so basically what I have done here, I have made the first layer, then second layer, and then I'm getting the output. Here in the middle of that, suppose I am applying the threshold function itself. There are weights, this is my input layer. So this is called multi-layer neural network. And also these in between the layers, these layers, basically these layers are called as a hidden layers. Okay, why hidden layers? Because we can directly see the outputs, we are not able to see the what happened in between, okay. So these are the called hidden layers. So I am hoping now that this structure is clear. There is one more thing here. When I'm saying that let's keep this threshold, okay, when I derived this equation xi wi, xi equals to 1 2 3 should be greater than my threshold. When I said this thing, can I do this thing or like just write it mathematically? Xi wi, okay, minus threshold should be greater than 0. Here I am making it more generalized. I don't know, it will be number of 3 parameters on which my decision is based. Let's take some j. J is the total number on which my decision is based. Okay, so when I say, okay, I have kept it, this is mathematically correct. Now I'm saying, rather than it keeping it minus threshold, I'll say this is called plus b. That is called my bias. So this is how a bias comes into the picture. When I'm saying what is bias, I'm adding a bias. It means bias is a kind of measurement to know that how easy it is to get the perceptron to the output 1, or I would say how much willing I am to get this job, because in that case I'll keep my threshold minimum, and when I'll keep it minimum, it means I'm increasing this bias because it's negative, right? So this is how I add the bias. When I'm adding a bias, then I just want to understand that how much willing. Sometimes we do, right, that we say lots of factors are dependent, but I'm not sure. Sometimes we are biased. We say no, we are biased about nature because we are biased about taking one kind of decision. It's like we are more probable to take this decision. If I am saying I am really more willing to join this offer, or I'm more willing to accept this offer, I'll keep this threshold for, I'll keep it very low, 3 or maybe 2 or maybe 1. If I keep 1 or 2, so I can say the minimum, it's not just 3 factor on which it is dependent, like 2, maybe if I keep 3, then everything will work out, right? Or maybe even one factor, I'm keeping it 1, threshold is 1. In that case, even if one factor is valid, even if salary is high, or maybe they are providing work from home, or maybe this is just relevant job, then also you will be willing to take this offer. So this is how bias plays a role. So I'm hoping now this architecture is quite clear with you. You can take any decision. This is the basic neural network, and now slowly we will increase its complexity, how it is mathematically derived. We will see that also, and also here right now I'm just keeping a threshold name. We will see that actually what it is called in technical terms, how do we define it, everything related to the terminologies and small functions. We will discuss it in the next lecture.